So in section 4 of chapter 8, we're dealing with some means. Now we're looking at doing a hypothesis test on means. And so as you've read, you've done some things with the t-distribution in section 4. So using a table of critical t-values of the t-distribution, find the range of values for the p-value for a two-tailed test with a sample size of 16 and a test statistic of 2.244. So you can look on their table that they have. I want to show you how to do it on StatCrunch as well, and we'll verify it's the same as the table. But if we go to calculators and we have a t calculator, so the t distribution is very similar to a normal distribution. It's symmetric, it's unimodal, but it's a little bit thinner than a normal distribution, and it's because of our small sample size that we have. So initially, the t distribution has a fun story. It was a gentleman who was working for Guinness and dealing with sample sizes came up with this distribution. So it kind of has a fun story. Degrees of freedom, what that is sample size minus 1. So if our sample size is 16, our degrees of freedom is going to be 15. So it's a sample size minus 1. And we're trying to find the range of p-values for a two-tailed test and a test statistic of 2.244. So if I go to 2.244, and if I want to see what's to the right of that, I see there's that much to the right. But since it's two-tailed, it also means I have this much to the left. So again, we would have to double that number to find out what the p-value is. So if I double it, I'm roughly getting 0.04, and I think that'll be enough to help me on this particular problem. So if I double it, 0.04, I should get C as an answer. So don't be tricked with picking A, because that's only one side. If it's a two-tailed test, you have to double that p-value, or that area to the right. Now, another one I want to look at is number 5. It should show you how to set up these problems. Again, I'm going to use StatCrunch to do it. So, assuming that a simple random sample has been selected from a normally distributed population, so that's important, so we can use this t-distribution. Identify the null and alternative hypothesis, test statistic p-value, and the final conclusion. So, a coin mint has a specification that a particular coin has a mean weight of 2.5 grams. So this is what's believed. This is our null hypothesis. A sample of 37 coins was collected. These coins have a mean weight of 2.49476, so really close to 2.5, and a standard deviation of this. So our alpha is 5% significance level to test a claim that this sample is from a population with a mean weight of 2.5 grams. Now, did anything say increase or decrease or imply a majority of something? I did not see that. So my null is that it equals. My null will always be that it equals. My alternative is going to be, is it not equal, less than, or greater than? So this one, to me, doesn't say less than or greater than anywhere, or imply it. So this would be a not equal to alternative hypothesis. So this is what's believed. That's our null hypothesis. And the only thing we're doing with our alternative hypothesis is changing the inequality. It's either a less than, greater than, or a not equal to. So now identify the test statistic. Well, again, there's calculations in the book. Or we go to our StatCrunch and we do a t-stat. So I think we've done a proportion stat. Now we're doing a t-stat. One sample with summary. And we have all this information. The sample mean is 2.49476. Sample standard deviation is 0.01437, and the sample size is 37. The believed mean is the 2.5, the alternative is that it's not equal to. So again, we just type in our information that we're given, and we have our test statistic, we have our p-value, we have that sample mean that, again, I think we provided that. But that should be everything to answer our question. Our t-value is negative 2.21800, 3 decimal places, right? Now when we plug in our p-value, this already gives us a doubled amount since it's a not equal to problem. So we just type it in. We don't have to double anything. And so 0.0329 is our p-value. And so we're comparing this to a 0.05 significance level. Again, just like last time, if the p is low, the O gotta go. This p-value is less than our alpha. Therefore, we are going to reject the null hypothesis. So there is sufficient evidence to warrant rejection of the claim that samples is from a population with a mean weight equal to 2.5 grams. So if the p-value is less than the alpha 0.05, we reject. Do the coins appear to conform to the specifications? Well, we rejected the fact that they were 2.5. So, I mean, they're really close, but we would say no, since the coins seem to come from a population with a mean weight different from 2.5. So again, we said that we don't think it's equal to 2.5. We rejected the null hypothesis, and the null hypothesis was that it was equal to 2.5. So no, since the coin seems to come from a population with a mean weight different from 2.5. So that should help you with this section 4.